Welcome to Cool Paradigms. The universe is logically infinite in time and space. The infinity of time, or if you prefer the never starting or ending global possibility of motion, avoids to theorize a magical appearance and a near disappearance of our universe with an eternal inflation. So something appearing from nothing is considered impossible in all fields of physics. Why would it be different for our global universe? Symmetrically, a return to nothing or almost nothingness in the global universe through infinite dispersion of entities forever lost in a staggering coldness without ever encountering anything else seems just as unlikely as magical apparition. No arbitrary spatial limits. If a spatial limit is supposed, what's coming after? If the answer is nothing, it should be empty space, which is not nothing and probably not inclined to remain empty infinitely far, and if it's an obstacle, even an insurmountable one, it's certainly something. In the same context, if we were trapped with everything else we can detect in some sort of predetermined shape defined by the evolution of our Big Bang event, it does not contradict the possibilities of an infinite number of entities external to that shape. In other words, undetectable does not mean non-existent. In cosmology, infinity avoids anthropocentrism. How many times in history has science been slowed down by anthropocentrism? Firstly, assuming that everything revolves around the Earth, then assuming a solar system with tiny fixed stars in a celestial roof not necessarily too far away and held in some unknown way. Then our galaxy, the Milky Way, alone in the universe, and at last other galaxies with billions of stars observed. But as we hadn't seen exoplanets yet, our solar system must have been exceptional. And finally we have now detected thousands exoplanets. But for the infinity it's a different story, because by definition we'll never see it in its entirety. Does this imply that we cannot admit it, even though abstract logic, common sense and science history strongly imply the existence of an infinite global universe? Common anthropocentrism, the common need to establish a beginning and an end. The tendency to place limits exactly where we see them. Even everything suggests that the overall universe is limitless. Apeirophobia, which is literally the fear of the infinite encountered in various situations not necessarily involving the entire global universe. Possible scientific consequences of a better acceptance of cosmological infinity. An infinite global universe involves gravity detectable at incredible long distances, allowing us to infer the average gravitational density of what is external to our Big Bang bubble by measuring the excess acceleration of galaxy clusters. An infinite global universe means an infinite amount of time to mix components, probably resulting in greater homogeneity than initially assumed. An infinite global universe involves two opposing paradigms: homogenization due to mixing things over and over an infinite amount of time, and heterogenization due to extreme distances and speed limit of the considered entities. We may have local homogeneity in Big Bang clusters and heterogeneity between clusters. The infinite global universe, as we can observe part of it, is probably recycling its components with a reasonable speed compared to its global evolution. For example, if black holes cannot at a certain stage of their evolution return the matter they have kidnapped, the entire universe would be almost only made of black holes. So black holes are likely to explode into big bangs. An infinite global universe probably involves reasonable recycling cycles to allow the observable part of the universe to exist as it does, unless we are in the extremely rare case of having escaped the long-term black hole compression, and rare and unique just for us recalls the general anthropocentrism tendency proven wrong over and over. An infinite global universe inevitably raises questions on much larger scales. For example, multiple Big Bang bubbles could interact and form gigantic structures with new properties. An infinite global universe is the acceptation of a non-unique Big Bang, with space-time infinitely present, and perhaps an opportunity to entertain thought experiments about infinite speeds or a freeze of time just to allow, in theory, perfect synchronicity. Following this, space-time equations are an excellent and beautiful mathematical model for managing various calculations related to different astronomical observations, effectively allowing very precise extrapolations taking into account the speed at which electromagnetic waves reach us and the gravitational curvatures they follow to do so, and so on. But in my opinion, the general theory of relativity should not be considered as an exact representation of reality, but just as a tool to observe it along with common sense. By the way, while speaking about limits, your excellent list of already subscribed videos is certainly very far from its maximum capacity. Thank you for your attention.